Hi guys, taking a look here at Mrs. Kennedy's note she let us use for general form of a conic section. Just something I wanted to kind of clean up for us. I thought we'd go over them just a tiny bit, and then I'll put my own spin on it. But she has some really good notes in here. The general form of all these conic sections kind of have the same flair. They kind of look similar, and there's little differences. There are things we can spot on there and decide, well, which conic section am I looking at, without having to go through the whole process of completing the square, finding all the key features and that sort of thing. So I'm going to scroll down here. She has some good stuff up there, but we're going to talk about this general equation right here. Ax squared, bxy, cy squared, dx, ey, and f. This thing, just knowing some things about these numbers right here can really tip their hand. They can tell us what conic section we're dealing with, okay? So we'll put a little summary together here of this. I'm going to write it right now, and then we'll talk about it. So it's ax squared plus bxy. That xy term is kind of weird, and she talks about that. Most of the time, if you have an xy term, you're going to have a rotated conic section. Just 1 over x actually ends up being one, and it's a hyperbola that's been rotated, but we're not going to talk about that. It's kind of beyond the scope of what we're dealing with right now. And we're going to deal with when b is equal to 0, and we have that other stuff. So I'm going to switch this over now. Let's look at what I'm talking about. Here's that equation that we just talked about. We're kind of saying when b equals 0, that's all the ones we're talking about. When b isn't 0 and you have this xy term, they're rotations. But we're going to ignore that for now. We're saying when b is 0, we can look at our equation and tell what it is. Here's the first thing. If a is exactly the same as c, if what's in front of the x squared term is exactly the same as what's in front of the y squared term, we have a circle. Okay? They're both being squared, and they have the exact same sign. They're the exact same number. They're being stretched in the horizontal and vertical direction the exact same amount. That ends up being a circle, exactly the same. Okay? If one of them is 0, if a equals 0, that means there is no x squared term. There's only a y squared term. That means it's a parabola, and it's actually an x equals y squared parabola, so that's a side opening parabola. So I'll put like this. I don't want you to think it's a hyperbola, so we'll just leave it like that, a side opening parabola. If the other one is 0, if c equals 0, it's a top opening parabola, top or bottom opening parabola. Okay? Only one of them being squared is telling me right off the bat it's a parabola. And then which one we're talking about tells us if it's side opening or top opening. Okay? The next one. If a and c have the same sign, but different values, that makes it an ellipse. So if they're both positive, but one's 6 and one's 10, an ellipse. They're both negative, one's 7, one's 15, ellipse. They have to have the same sign, but different numbers, right? Because if they're the same number, that'd be a circle. It's an ellipse. And then finally, if a and c have opposite signs, doesn't matter what the numbers are, if one is positive and one is negative, that's a hyperbola. Okay, so we have this nifty little chart here. If a and c are both 0, that's a line. It's just going to be a x and y term. A point is just a point. I think that covers them all. Okay, so that's a little shortcut, a little summary of the notes Miss Kennedy gave to us. I gave you guys a little quiz on Google Forms to take and check and see if you know what we're talking about here. There's some in your book as well in the conic section part. Look through it and see if you can just look at it, something in general form, and say, hey, I know that's an ellipse, or I know that's a hyperbola. All right. Quick video. See you guys.